Drop a pen. It falls every single time, without fail, without exception, without needing to be told. Somewhere in a distant galaxy, a star collapses. The same rules that dropped your pen are the rules that pulled that star apart. The same equations, the same constants, the same physics. Now ask yourself a question. Nobody taught you in school. If everything in the universe follows the laws of physics, who decided what those laws would be? Not who enforces them, not how they work. Who decided them? Before the universe existed, before matter existed, before time itself existed, because those laws had to come from somewhere. Or did they? Here is what makes this question so unsettling. The laws of physics aren't like human laws. You can break a human law. You cannot break the law of gravity. You cannot negotiate with entropy. You cannot ask the speed of light to slow down for you. These laws are absolute. They are universal. They apply to every particle, in every corner of existence, at every moment in time, and they were apparently in place before the very first moment of the Big Bang, because the Big Bang itself obeyed them. The way matter formed, the way forces separated, the way the early universe cooled and structured itself, all of it followed physics before a single star had formed, before a single planet existed, before any mind had ever wondered about any of it. So the question is not just interesting, it is genuinely one of the deepest puzzles in all of science and philosophy. What is the origin of the laws that govern everything? To understand why this is so hard to answer, let's trace the question step by step. Step 1. The laws work everywhere. Begin with the most remarkable fact about physics, its universality. The same gravitational constant measured in a laboratory on Earth today matches the gravitational behavior of galaxies billions of light years away. The same electromagnetic equations that describe a circuit on your desk describe the radiation from a pulsar spinning 1,000 times per second in deep space. No exceptions have ever been found, not one. Across every scale, every distance, every era of cosmic history we can observe, the laws hold. This universality didn't have to be true. The universe could have had different rules in different places. It could have been patchy, chaotic, ungoverned. The fact that it isn't, the fact that a single consistent mathematical framework describes all of physical reality, is itself something that demands explanation. Step 2. The laws are mathematical. Now add the second remarkable fact. The laws of physics are mathematical, not just described by mathematics. They are mathematical. The equations are not summaries of the physics. They are the physics. Remove the mathematics, and there is no physics left to describe. This is strange. Mathematics is something human minds invented or discovered to count, measure, and reason, and yet, somehow, the universe was built using it. The universe runs on math in a way that is so precise, so deep, and so consistent that physicist Eugene Wigner called it the unreasonable effectiveness of mathematics in the natural sciences. He meant, there is no obvious reason why the universe should be mathematical, and yet it is, to a degree that seems almost miraculous. D3. The laws have specific values. Finally, consider the constants. The laws of physics don't just have mathematical forms, they have specific numerical values. The gravitational constant, the charge of an electron, the mass of a proton, the cosmological constant governing the expansion of space. These numbers are extraordinarily precise, and they appear to be tuned. If the gravitational constant were slightly larger, stars would burn out too quickly for life to develop. If it were slightly smaller, matter would never condense into stars at all. The charge of an electron, the mass of the Higgs boson, the rate of cosmic expansion, every one of these constants sits in a narrow range that permits complexity, chemistry, and ultimately life. Why those values? Why not others? Nobody has been able to explain it. Here is how science currently approaches the origin of physical law, and the answers are extraordinary. Possibility 1. The laws had to be this way. Some physicists and mathematicians believe the laws of physics are not arbitrary. They are mathematical necessities, truths that couldn't be otherwise, like the fact that a triangle's angles add to 180 degrees in flat space, Under this view, the universe doesn't follow physics because someone chose these laws. It follows physics because these are the only self-consistent mathematical structures that could produce a stable, complex reality. Any other set of rules would be internally contradictory or produce nothing at all. Possibility 2. The laws came from nothing. With the universe, Stephen Hawking and others proposed that the laws of physics are not external to the universe. They emerged with the universe from the quantum foam of nothing. In this view, asking what governed the universe before the Big Bang is a meaningless question. Because before the Big Bang, there was no time in which anything could be governed. The laws didn't pre-exist the universe. They are what the universe is. At its most fundamental level, the universe is a mathematical structure, and the laws are simply what that structure does. Possibility 3. There are many universes, each with different laws. String theory suggests that there may be an almost incomprehensibly large number of possible universes, sometimes called the string landscape, each with slightly different laws, different constants, different physical properties. We find ourselves in a universe with the laws we have because those are the laws that permitted us to exist. The other universes, with laws that don't permit complexity, exist, but without observers to notice them. This is called the anthropic principle. And while it explains why we observe what we observe, many physicists find it unsatisfying because it doesn't explain why any universes with any laws exist at all. Possibility 4. The laws are emergent. Perhaps the deepest current proposal is that the laws of physics are not fundamental at all. They emerge from something deeper, a mathematical structure, a quantum information network, or a framework we don't yet have the tools to describe. Just as temperature emerges from the average motion of molecules, temperature is not fundamental. Molecules are. The laws of physics might emerge from some underlying reality we haven't yet discovered. Here is the twist that makes this question recursive in a way that should genuinely stop you. Every explanation for the origin of the laws of physics introduces something new that requires its own explanation. If the laws are mathematical necessities, what is the origin of mathematical necessity? What makes mathematics itself necessary rather than arbitrary? If the laws emerged from quantum foam, what governed the quantum foam? What are the laws of quantum foam, and where did those come from? If there is a multiverse, what are the laws of the multiverse? What governs the process by which universes with different laws are generated? If the laws are emergent from a deeper structure, what are the laws of that deeper structure? The chain of, but what caused that, appears to have no bottom. This is what philosophers call the problem of infinite regress, and physics, for all its extraordinary power, has not yet found the floor. So here is the honest answer that science gives us right now. We do not know where the laws of physics came from. We know them with extraordinary precision. We can use them to predict the behavior of particles and galaxies with accuracy that staggers the imagination. We can build technologies that depend on their consistency to function. But why these laws? Why any laws? Why not something else or nothing at all? No physical experiment can answer this, because any experiment takes place within the laws of physics. You cannot step outside of physics to observe where physics came from. The instrument you would use to make the measurement is itself made of physics, governed by physics, explainable only by physics. This is the deepest form of the question: can the universe explain its own foundations? Or is that question, by its very nature, beyond the reach of any mind that lives inside the universe? Here's the thought that should stay with you. You are, in the most literal sense, made of the universe looking at itself. Every atom in your body was forged in the heart of a star. Every particle follows laws it did not choose. Every thought you are having right now is a pattern of electrochemical signals in a brain that runs on physics. And yet, through some chain of consequences so long and so improbable that it seems almost impossible, that physics produced something that wonders about it. The universe made rules. The rules made stars. The stars made atoms. The atoms made you, and you sat down one day and asked, but who made the rules? Maybe that question has no answer physics can give. Or maybe the question itself, the fact that the universe produced something capable of asking it, is the most important thing about it. A universe that cannot be questioned is just machinery. A universe with a mind inside it, asking why, that is something else entirely, and you are that mind, right now, asking.